13.3 Evaluate trigonometric functions of any angle. So today, for all of you guys out there, I have a really good pickup line. I'm telling you, Harry, she's really the one. She's cosine of 90 degrees. See if you get this one in a minute. So now we're going to just define sine, cosine, tangent, cosecant, secant, and cotangent in general. So on any circle with the radius r, we can define the 6 trigonometric functions. And I don't know if you know this yet, but this is super important. This is the equation of a circle. X squared plus y squared equals r squared. That is the equation of a circle, how you would graph any circle. And so how do we define these 6 trigonometric functions? Make sure you're concentrating really, really well right now, because this is super important. What I want you to think of whenever we have this unit circle and we're doing any trig stuff, I want you to go back to your right triangles. You could stick a right triangle. I'm just going to go ahead and put it in the first quadrant. I know this triangle's in the second quadrant, but I'm going to put it in the first, just like this. And so now my theta is just this angle. And your theta in any triangle that you put here is always going to be coming from the origin, okay? So it's always going to be touching that. That's where your theta is going to be coming from. Now, of course, since we're on the xy plane now, this length here is just x, and this length here is just y. And since we're on the circle that we called it with a radius r, this length right here is just our r. And so what is sine of theta? The sine of theta is just going to be y over r, opposite over hypotenuse. Our cosine is just going to be adjacent, which is the x, over the hypotenuse. And our tangent is just going to be opposite over adjacent. I do want to make sure that the x does not equal 0, so we don't divide by 0. The cosecant, we just flip it, we get r over y. The secant, we just flip this, so we get r over x. And the cotangent, we flip this and we get x over y. So understanding that whenever we do things on the unit circle that we can just plop a right triangle inside of it, call this side x, because we're on the xy plane, this side length is x, this side length is y, and make sure that your triangle goes back up to the circle so that we can call this side length r, our radius. So now let -9, -40 be a point on the terminal side of an angle in standard position. So what that means is that -9, -40 is over here. And it is important that we keep in mind where we are. So the triangle that we make, always we need to make sure that it comes back to the x-axis. That's super important. And so we just bring it back up here. And then remember I told you the angle always is going to come from the origin. So our triangle is just going to look like this. Let the x be the -9, and I know that side lengths can't be negative, but please put the negative numbers so that you make sure that the signs of all your trigonometric functions are right. So this is -9, this is -40, and then how do we find this side length? We have to do a squared plus b squared is equal to c squared. So let's go over to our calculator. So if you're going to do -9 squared in your calculator, you must have those parentheses. Otherwise, you're going to get the wrong answer every time. Plus -40 squared. And then to get c, we just need the square root of that. So I'm going to just do the square root of second answer. And I get 41. How nice. So c is equal to 41. So I have 41, and this is positive. The hypotenuse, in fact, is always going to be positive. So now I need to do the 6 trigonometric functions: sine, cosine, tangent, and then we'll flip them. This goes with the c, cosecant, secant, and cotangent. So sine is just, here's our angle. Remember, it always comes from the vertex. So we have opposite, which is -40. So you see why I want you to put the signs there? -40 over 41. Cosine is -9 over 41. Tangent, opposite, negative 40 over adjacent, negative 9, and that's 40 over 9. Flip all these things, we get negative 41 over 40, we get negative 41 over 9, and then we get 9 over 40. The circle x squared plus y squared equals r squared, which has center 0, 0 and a radius 1, is called the unit circle. So here, the radius is equal to 1, which is what I was touching on in the last lesson. Remember when I said that's why the circumference is 2 pi? So the values of sine and cosine are simply the y coordinates and the x coordinates. What do I mean by that? I'm going to go ahead and put my triangle again in the first quadrant because I think it's easiest to think about there. And your theta, remember, is always touching this vertex, so your theta is right here. Since this is on the xy plane, this is my x, this is my y, and instead of calling this just simply r, I'm just going to call it 1 because my radius is 1 in the unit circle. That's why I call it a unit circle, 1 unit. So my sine is simply going to be opposite y over 1. Or just y. The sine is just the y coordinate. And cosine is adjacent over hypotenuse, so the cosine is simply the x coordinate. That's going to come in super handy as we go further. Use the unit circle to evaluate the 6 trigonometric functions of theta equals 2 pi. Well, let's think about this. 2 pi is right here on my unit circle, right? Remember, 180 degrees equals pi, so 2 pi is going to be 360 degrees, 1 full time around the circle. Now the problem is, before I was telling you should just plop a triangle in there. How am I going to plop a triangle in here? I can't. So think about, what are the coordinates right here? The coordinates are 1, 0. X is 1, y is 0. So sine, cosine, tangent. We need cosecant, secant, cotangent. So sine is just going to be the y coordinate, or 0. Cosine is just going to be the x coordinate, or 1. And then tangent is just going to be y over x, 0 over 1, which is 0. Maybe I'll put that on this slide. Tangent theta is going to be equal to y over x. Same logic, we have opposite over adjacent. And so secant, flip 0 over 1, and we get 1 over 0. That is undefined. Make sure you don't write that. You write undefined. But 1 we can flip and just get 1. And flip 0 over 1 and we get 1 over 0 again, or undefined. Now let's look at 270 degrees. 270 degrees is right down here on my unit circle. And this coordinate is 0, negative 1. So now let's do sine, cosine, tangent, cosecant, secant, and cotangent. So sine is just the y coordinate, or negative 1. Cosine, the x coordinate, or 0. And tangent is that negative 1 over 0, which we can't do, so it's undefined. The cosecant, flip over negative 1 over 1, and that's negative 1. Flip over 0 over 1, and we get 1 over 0. That's undefined. And then let's flip over negative 1 over 0, and we actually get 0 over negative 1, so this is actually 0. So make sure that when you flip undefined, you flip it right. Remember how I said, like, show your work, the intermediate steps? This is one of those cases. Show the negative 1 over 0 so that when you flip it, you get the 0 over negative 1. So the reference angle is going to be hugely important to us. The reference angle is what we actually use when we're making all these triangles on our unit circle. So remember that I just said that there's this one hugely important thing, that you always want to bring your triangle back up to the x-axis. And that your angle is always coming from the vertex. Say your angle's over here. Then your reference angle, if you went and brought this back down, okay, that would be your triangle. So your reference angle is just going to be right here. We were calling that theta prime. That's what they called it in the book. And so if this angle that they give you is theta, then theta prime would simply be 180 minus theta, right? That's how you would find this degree angle, since you know this is 180 degrees. And don't get nervous about this. We're going to do a bunch of examples in a minute. And if I wanted to do radians, then instead of doing 180 degrees, I would just do pi. Now, if my triangle was over here, then I bring this back up to the x-axis. It would look like this, my triangle. And my angle is always the one touching there, and so this would be my reference angle. And so how would I find that? Well, if this is my whole angle, and I just want to find this piece of the angle, then I need to subtract out the whole first top half. So I would do the whole angle thing, and I would subtract out the 180. So I'm just left with this part here. And I could just replace that with a pi. Now let's look at this triangle over here. If this was my side length, bring it up to the x-axis, there's my triangle. The angle always touches the vertex. So if this is my angle, well then 360 minus the angle is going to give me this piece, right? 360 is also known as 2 pi. So this is really nothing that hard at all. Just think back to geometry. You did all of this stuff. If I gave you this piece and you wanted to find this piece, you know that this plus this equals 180. So 180 minus this part is going to give you the missing piece. If you have this whole thing, but you just actually wanted to find this angle, well, you would just subtract out the 180, which was the top. This one, you have this part, but you actually want to find this. Well, you know the whole thing is 360, so 360 minus this part is going to give you this part. I think examples always help clarify things. So let's draw negative 295 degrees. Well, we know negative 270, and we go a little bit more around, right? So my angle is going to lie somewhere up here. So we know that this whole thing was 295 degrees. And so what is my angle? Well, the whole thing around would have been 360. And so let's just subtract off the 295. And so that's 65 degrees. And so that's my answer. It's just, what is this angle, given the rest? So now let's think of 7 pi over 12. Well, let's see. You know, this whole thing would be pi. And so since we're looking at 12, so why don't we call that 12 pi over 12, just to help us a little bit. And half of that would be 6 pi over 12. And so, you know, you've gone a little bit more than there. But remember, your triangle always comes back down to the x-axis. And your angle is always just this little guy there. And so what is that? Well, this is 7 pi over 12. How do we go from 7 pi over 12 to 12 pi over 12? Well, to go from 7 to 12, we need 5 more. 5 pi over 12. So when you're evaluating trigonometric functions, you do want to think about what the sign is going to be. You never need to memorize this because you're always going to just be putting all of these triangles on your coordinate axis, and it's going to tell you what the sign should be just naturally. But let's just think about it. So now I'm always going to group sine and cosecant together because their signs are always going to be identical. Remember, hypotenuse always must be positive. Cosine and secant are always going to have the same sign, and then tangent and cotangent are always going to have the same sign. So that's why I just grouped them together here. In quadrant 1, since both x and y are positive, that means that sine, cosine, and tangent are all going to be positive. But when we go to quadrant 2, we know that x is negative and y is positive over here, right? We have a negative x and a positive y if we're drawing triangles in this quadrant. So sine, which involves just y stuff, is going to be positive, but cosine is going to be negative. And then tangent, which is y over x, is going to be negative because a positive divided by a negative is a negative number. When we're in quadrant 3, we have our x is negative and our y is negative, which means that all our sine stuff, which relates to the y, is going to be negative. All of our cosine stuff, which relates to the adjacent side or the x, is going to be negative. But tangent, which is y over x, is positive because a negative over a negative is positive. When we're in quadrant 4, we know that our x is positive, but now our y is negative. So the opposite side, which is our sine stuff, or our y, is going to be negative. Our cosine is going to be positive, and our tangent, which is negative over positive, is going to be negative. So that's how we figure out the signs. But you'll see that I always draw pictures, so I don't actually need any of this stuff. I just wanted to talk you through it. So when we want to evaluate the sine of negative 225 degrees, the first step is to draw our picture and identify our reference angle. So negative 225 degrees, this is negative 180, this is negative 270, so it's going to be somewhere in between there. The next step is to drop down a side length, and that's your right angle, and this is your reference angle right here. So now you know this whole thing here is 225 degrees, and I went backwards because it's negative 225. So if I subtract out the 180, then I'm going to get just what theta equals. So theta is going to be that whole 225, subtract out the 180 degrees, so I just get theta. And that just gives me 45 degrees, which actually makes me really happy, because now that this is 45 degrees, I know these are unit circles, remember? So this is always going to be 1. And I remember that this is my root 2 over 2, and this is my root 2 over 2. So now when I ask you what the sine is, the sine of 45 degrees is simply the opposite over the hypotenuse, which is just root 2 over 2. So that means that the sine of negative 225 degrees is root 2 over 2. Final answer there. When I want to do cotangent, I immediately start with the tangent of 5 pi over 3. And then I'm simply going to flip it when I come up with my final answer. So before I start, let's make our picture. 5 pi over 3. Well, you know 6 pi over 3 is equal to 2 pi. So that would be 1 whole time around. But I stop a little bit short. How much short do I stop? I stop pi over 3 short, right? Because the whole thing around would have been 6 pi over 3, or 2 pi, but I only went 5 pi over 3. So I stop pi over 3 short. So let me just magnify that right triangle that I have right there. That's this triangle that's sitting right there. I'm just magnifying it. Pi over 3 is equal to how many degrees? Well, remember that pi is 180. So 180 over 3 is 60 degrees. So now I'm looking at my 30, 60, 90 triangle, remembering that this was 1, the one opposite the 30 is a half, and the one opposite the 60 is root 3 over 2. So when you ask me tangent, I simply say that the tangent of 60 degrees, which is the tangent of pi over 3. Well, that is simply opposite over adjacent, which is root 3 over 2, keep it, change it, flip it, which is just root 3. Now, before I go any further, you wanted to do this at the very beginning, I want to identify, this isn't simply 60 degrees in the first quadrant. This is actually my 5 pi over 3, so it means that I'm in this quadrant over here. And so this was a negative side length, right? Because the x is positive, but the y is negative over here. So make sure that this is negative, and then this is negative, and then this is negative, and so my whole thing is negative. And so when I do the tangent of 5 pi over 3, you need to make sure that your signs are in check. You just have that negative root 3. When you go to do the cotangent, you do have to flip that 1 over negative root 3. And of course, I need to rationalize that denominator, so multiply by root 3 over root 3. And you're left with just negative root 3 over 3 as your final answer. So in summary, when you're doing these problems, make sure that you draw the picture so that your signs are correct, and make sure that you're putting the positive and negative signs if your y coordinate is positive, if your x coordinate is negative. Here, your x coordinate was positive, so that's positive, but your y coordinate was negative, so this was negative. And that's it for this lesson.
Bye.